We have 3 problems remaining, and these 3 problems we will be using either the double angle or the half angle formulas. So on your formula sheet, here we are. Of course, if you recall, for the double angle formulas, if you're looking for the cosine, you have 3 choices. And then the half angles, there's some extra work to do because these answers they're either plus or minus. They're not both. They're either plus or minus. And before we even do the calculation, we have to determine if it's plus or minus. So here's the first problem. These actually aren't too difficult, these first couple. This is similar to what we did with sum of difference formulas, where we're asked to find the exact value of an angle, and we look, and in this case, cosine of 165. 165 is not in the unit circle. Now I know it's going to be in the second quadrant. So if I'm looking for the cosine, I know the final answer is going to be a negative number, but there's no way I can get the exact value. However, here's the key to doing this problem. Let me just write it out here. So here's the ultimate goal of the problem. What is the cosine of 165? An exact value. The key to this problem is realizing that if I can find an angle, in this case, 330 degrees, if I can find an angle, and in this case, it's a special angle, so that's the key. I should have said that. If I can find a special angle, I look here, 330 degrees is on the unit circle. If I can find this special angle and then divide it by 2, and if that equals the angle I'm looking for, then I can actually use these half angle formulas to find the cosine of 165 degrees. Now if this wasn't obvious to you, just so you know, if you have a problem like this, maybe the easiest way is you take your initial angle and you multiply it by 2. And if this angle here is a special angle, then you can do what I've shown here. So maybe what I should have done before I started, could have said, well, let's take our initial angle, let's multiply it by 2. Because the initial angle is not a special angle. I multiply it by 2 and I check, and this is a special angle. If I can make that happen, then I can say to myself, well, that means 165 is 330 divided by 2, where 330, the whole key to this is a special angle. Let's go and do this problem, and you'll see how that makes all the difference, because I'm going to now, I'll write it this way. Cosine of 165 degrees, I can rewrite that as the cosine 330 degrees over 2. And if I want to go use my formula sheet, I'm going to we'll just call 330 degrees the angle theta. And now I go to my formula sheet. Cosine and angle divided by 2 equals this. Now in our case, I know my final answer is going to be a negative number, so I will put the negative, so I will write this out. The formula says this equals a negative, well, let me put plus or minus 1 plus the cosine of theta over 2. Hopefully you can see I'm going to replace theta with 330 degrees, and then I'm going to, I know the answer has to be negative. So the cosine of 330 degrees over 2, just to make it very clear, which equals the cosine of 165 degrees. Using this formula is negative 1 plus the cosine of 330 degrees all over 2. Now, the cosine of 330 degrees is a special angle from the unit circle. What's the cosine of 330 degrees? Square root of 3 over 2. So I have 1 plus square root of 3 over 2, all that over 2, and that whole thing is still inside a square root. Now I need to simplify this. First thing I'm going to do is I'm going to change this 1 to 2 over 2 and combine this into one fraction. So it ends up being 2 plus square root of 3, all that over 2, and all of that over 2. Now to simplify this complex fraction, this 2 simply goes up here. So now I have 2 plus square root of 3 over 4. Now, in the denominator is a 4, square root of 4 is 2. So I can now write it like this. Still pretty messy, but that is actually the exact value of the cosine of 165 degrees. Now I believe we're going to do another one of these, except now it's going to be in radians. A little more complicated. Sine of negative 3 pi over 8. So it's in radians, plus it's also a negative. So let me, especially for this one, it's going to be helpful to use the method I sort of talked about for the last problem. 3 pi over 8 is not on the unit circle, so they're asking for an exact value. I'm sort of stuck. But to see if I can use a half angle formula, the way I'm going to check it, just like I did this one, I'm going to do this now. This is sort of like the way you check to see if a half angle formula can work. You take your initial angle and you multiply it by 2. So I'm going to take the initial angle and multiply it by 2. So if you do that, you get negative 3 pi over 4. Now, when you do that, if this result is a special angle, then you actually can use the half angle formula to find the sine of this angle here. And you know what? Negative 3 pi over 4 is a special angle. Now because it's negative, actually negative 3 pi over 4 is right over here. So eventually we'll probably have to know some trig functions, but that's where negative 3 pi over 4 is. And just so you know, this initial angle, negative 3 pi over 8, is actually going to be in this fourth quadrant. and the sign of that is going to be a negative value. So when I use the formulas, it's going to be a negative answer. So let's go ahead and look at the half angle formula. So let's write it out this way. Let's say the sine of negative 3 pi over 8. This is going to be a little messy, but unfortunately we work with fractions here. That's the same thing as negative 3 pi over 4 over 2. Because if you look at this, they get 3 pi over 4 over 2, complex fraction. If you simplify it, the 2 goes up and gets multiplied by the 4. So this thing inside here does equal negative 3 pi over 8. But the key is now I can imagine this to be theta over 2, where theta is negative 3 pi over 4. And because that's a special angle, then I can go ahead and use my half angle formulas. So the half angle formula for the sine of your angle divided by 2 is this, and I'm going to make sure it's negative. So let me just write out that formula. One minus cosine of theta over 2. So theta is negative 3 pi over 4. So 1 minus cosine of negative 3 pi over 4 over 2. So cosine negative 3 pi over 4, I said a minute ago, is actually right here. So it's negative square root of 2 over 2. So I have a negative 1 minus a negative square root of 2 over 2. All over 2. So when you subtract the negative, it's really adding. Now, if I want to add these together, I convert the 1 into 2 over 2. And if I do that, then I end up with 2 plus square root of 2 over 2 all over 2. This 2 can be multiplied by this 2. 2 plus square root of 2 over 4. And now square root of 4 comes out as a 2. And you end up with 2 plus square root of 2 over 2. I've said before, these half angle formulas, you have a square root and inside is a fraction. It can get very messy. But that would be the exact value of the sine of negative 3 pi over 8.